Okay, here's an answer to a couple of questions that some people have had. First one refers to graphing, and it says, describe how the graph can be obtained from the basic logarithmic function graph. And then they say, then graph it. Give the domain vertical asymptote of each function. We didn't really talk a whole lot about vertical asymptote, but I can talk a little bit about that. Anyway, the graph of a normal y equals log base 3 of x um, logarithmic function would look sort of like this. It's the inverse of an exponential graph, so it'd have to look something like this. Go like this, and then start going like that. Something like that. So that would be the base one, is that dark blue one. Notice that this line here goes down and down. It gets closer and closer to the x-axis, or the y-axis, but never touches it. So the y-axis is called the vertical asymptote. Vertical asymptote. So that is a normal graph. Now if I look at the transformations that I've done with other ones, I look at this and I see that this minus 1 is in the D spot. So in other words, it's a vertical translation, either up or down. And since it's minus 1, that will mean that the graph will move down 1. Okay, so the graph is going to move down 1 unit. Notice there's no other transformations. There's nothing out front. There's nothing in front of the x or right behind the x in brackets. Remember, this is what it would, where all those letters would be. Log base 3 of bx minus c plus d. That would be sort of the general function. And my minus 1 is in the d spot. So I just would have to take this same graph that I've got and move it down 1. So it would probably look something like, I don't know, something like that. So everything would be moved down 1. Maybe a couple important points might be like this one where it crosses the x-axis. That might be a nice spot to know. And I could know that just by solving this equation. So if I took the equation y equals log base 3 of x minus 1, and if I solve it for a y value of 0, so it'd be 0 equals log base 3 of x minus 1. Take the 1 to the other side, 1 equals log base 3 of x, and then change this from logarithmic form to exponential form. So it'd be 3 to the first is equal to x, or x is equal to 3. So that point right there, where it crosses the x-axis, would be 3 and 0. Okay? Hopefully that gives you an idea of how to graph that and how to recognize at least one of the transformations. Another question had to do with using a logarithmic equation and using that to solve a problem. So here it says average walking speed, so that's W, in feet per second of a person living in a city of population P in thousands is given by this function. So we want to know what the walking speed in each city would be. So here's my formula. The walking speed in a certain city with a given population is 0.37 ln of p plus 0.05. So I'm going to take and just plug in any one of the numbers that they gave me. Ln of, okay, let's pick, I don't know, Chicago. So ln of 2,862,244, and then plus 0.05. Now doing this on your calculator, what I would do, if you have a graphing calculator, you can just type it in as is. If you don't, if you're going backwards, I might figure out what the ln of that big number is, and then multiply it by 0.37, and then add 0.05 to it. Okay, so just plug the numbers into a formula, and that'll tell you what the walking speed in Chicago is. Okay, hope that helps out.